All right, good morning, everybody. We are on to chapter 10, section 3. This is the point of the chapter that we have not seen before spring break, so we're now entering the totally new pieces. The title for it is Arcs and Chords. Arcs and chords. We've talked about those before. We're just going to go deeper into them and kind of talk more about how we can know things about them. As always, we have the preamble, some things from the previous lesson. We have a circle O, BD is a diameter, and AOD, AOD is 55. Find COB, COB. This is a pretty tough one. I would pause this one and try to solve it on your own. If you want to know how to solve this, this is a good example of one where we actually don't need the 55. We actually just need these two. These two add up to be 180, so I can just set those equal to each other, or not equal to each other. We can add them together, so 4x plus 10x is 14x, plus 18 minus 6 becomes plus 12. Then we set that equal to 180. And we should get 114 for this total angle. Similar one, you're finding DOC now. But once we found X, we can just throw that back in. So it's once we did the first one, the second one should be easier. We'll skip these and jump into the lesson. If you have any questions about 10.2, don't be afraid to reach out. There's also office hours. We'll try to find how to do those best soon. All these slides are on Schoology, and that's what I'm going to go off of. So we're starting with this. You can ignore the proof right now. This might be more distracting than helpful, and we'll focus up here. So in the same circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So let me copy this down here. So this is circle L. We have F to G. And then J to, it looks like H. You have J to H. And what this is saying is if I look at these two chords, and I find this measure and this measure match, so these are congruent like this, because remember they're just segments. That means this measure and this measure match. So let's write that over here. So if FG is congruent to JH, then measure FG is congruent to measure. Remember, we call it FG because that is our minor arc. Our major arc would go around like this. So what we're saying is if these two lines are the same, that means these two arcs are the same as well. This is the proof to sort of show you how they got there. Hopefully you take a minute to just look at it, see if you can follow along. I bet you probably can, more than you think. So we have a circular piece of jade is hung from a chain by two wires around the stone. We're given JM and KL match. Those are the segments. And M, the measure of KL is 90. So this is 90. Since we know that, we know JM is going to be 90 as well. Simple as that right now. But it always starts off that easy, but doesn't ever stay that easy. So let's start to build up. We have this RS, this arc right here, is 85. TV must be 85 as well because of these congruent symbols. If they looked close to being congruent, but we weren't given it, we couldn't know it. If this went just over here a little bit, it might not be congruent anymore. Perfect. Now we're going to start building up, getting a little more difficult. In the figure, we're told A and B are the same size circle. We're also told W and X and Y and Z match. Find WX. So this should be a pretty straightforward problem. We have two circles. And we're told that these match. This was 7x minus 2. Here, I'll put it back up here. And this is 5x plus 6. So a couple layers of things we had to know first. And if those did not happen, we can't solve this problem. First, we have to know A and B match. If we don't know that, these are just two circles, they could be anything. We also had to know these two match as well. And then because of that, I can take these two pieces, put them together. 7x minus 2 matches 5x plus 6. These two pieces come together. Add 2, minus 5x minus 5x. 2x equals 8. X ends up as 4. Oh. We're given both of those. We know that the chords and the arcs work together. They match together. So they are congruent. So we solve them just like we would. We stopped here at 4. The question asked for WX, so we take 4 and plug it back in. So give this a try on your own. You have these two circles. We're told they match. We're told RT and LM, the arcs match, so we know that those chords must match as well. Take a minute, pause the video, try to solve it on your own. And if you got an answer, hopefully you got 13. 13. Not only do we have that, we have some other things. If a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord at its arc. Then the perpendicular bisector of a chord is a diameter of the circle. So a perpendicular bisector of a chord is a circle. So something like this is important, not because it's something you should be memorizing, but something you should be understanding that with circles, it's sort of like we started the semester off and we talked about triangles, and we kind of took triangles and went to quadrilaterals, and we took quadrilaterals and went to rectangles, and we talked about rectangles, and eventually we went to squares where everything started matching. And the more that matched, the more we got to see how things came together. So circles are sort of the biggest, the kind of next step in this, where everything's starting to match, where every radius is going to be the same length. But now what we're saying is there's even more symmetry in anything we do. So the perpendicular bisector of a chord is a diameter or a radius of the circle. So if I draw a circle and I draw a chord, doesn't really matter where, and let's find the about middle of this. Doesn't have to be perfect. Let's say here. So that this line and this line match up. If I extend this, that should be a diameter all the time. So you can draw an infinite number of circles and try this for yourself where you say, okay, well, where's the middle? And they find that that's always going to go through the middle. That's all it's saying. So in circle G, we're told this is perpendicular. Find D to E. Now it's not 90 degrees. It's not 90 degrees. The reason it was 90 degrees last time is because this box right here was sitting touching our center. Since it's not 90 degrees right now, what we have to do, so we know this is a chord, it's not the diameter. Therefore, we know that this is also 5 as well, if we cared for that. But theorem 10.3 bisects DE, therefore, by substitution, we get this. So once again, 10.3, if a diameter of a circle is perpendicular to chord, then it bisects the at its arc. So we know this. When we see this guy right here, that means take 150 and cut it in half. So let's do this problem together. Let's do this problem together. We have a circle that we're going to put on our paper. We have a point Z in the middle. We have a radius from Z to U. We have a chord that isn't cutting through Z. So it's not cutting through Z, it's cutting through W. And this, we'll call this Y, and we'll call this X. We're told a couple things. We're told this is a right angle. And we're told this is 7. And then we're told this is 160 degrees. All right, so there's our problem. This is everything we're given. We have a chord cutting through. This is our center. We have this. This is our most important thing. In your notes, I would highlight this piece, because this piece is going to tell us something. It's going to tell us this is cutting over here, so that's 7 as well. But also, it's going to mean we're cutting this guy in half. So we're going to take 160. This is 160 divided by 2. This is 160 divided by 2. And so this piece over here is 80 degrees, and this piece over here is 80 degrees. Once again, because of our right angle, we cut that in half. And you can see how that would work on a regular circle if we had a diameter and a radius. It's something like this. We know that this is 90, this is 90, and the whole is 180. So it's not very different. What we're changing is what is our number over here, because if we move it closer, we're cutting off more and more of the circle. So if we have this is less than 180, and this is less and less and less, so this would be more than 180, more than 180. That's how we knew 160, cut it in half. So we look at our answers. Hey, we have 80 as one of our options. Great, we'll pick that. Ceramic tile. In the ceramic stepping stone below, the diameter of A to B, so the diameter cutting straight through is 18 inches long, and chord EF, E to F, is 8 inches long. Find C, D. Okay. So, if you can't see it, there is a square in the circle. There's a square in the circle. So let's redraw it. We have a circle. We have a square inside the circle. We have A over here, all the way cutting through B. There's your center. Here's your B, D, F, E, C, A. So what we're trying to find, that's the most important thing in every problem you ever do. We want this measurement right here. We're given a couple of things. We know AB is 18 inches long, and we're looking for CD. And we also know chord EF is 8 inches long. What they're doing right here is using the square. So if we didn't have this square, this is just some arbitrary point. But we do know that this is cutting right here. That this is cutting, let me zoom in. This is cutting right here, so this makes it a right angle. So if I make a little line right here, because I'm looking for this, if I add a little line right here, I can make a little right triangle. I can make a small right triangle. So down below here, I have C in my middle, up to E, and then down to F. This is what I want to know more than anything. I don't know if I have this. I might not. I do have this though. I have this by way of this. So I know E to F is a total of 8. So I know I have to split that in half. So that means my leg of my right triangle is 4. Means the leg of my right triangle is 4. So if we want to find C to E, our next step is to sort of say, well, what else? How can we figure this out? We've used what we think are most of our things, but we actually have something we haven't used yet. We have not used the diameter. Why did it give us the diameter? If you see here, this right here is a radius. You can see, try to block everything else out. This, to the outside of that circle and that corner of the triangle, it's where they all kind of congregate, is a radius. Well, this is the diameter, so I need to cut this in half. So my radius is 9 inches. Okay, so then I know this is 9 inches. And now all I have left is a small right triangle that I'm going to solve. I have all this stuff that I'm not going to use. I wanted to find this distance. I had to find the pieces that I need to get here. And now to solve this, I have my hypotenuse, which is 9 squared, equals 4 squared, plus, let's call it x squared. That's 81, 36, x squared. All right, I need 81 minus 36. That is 45. So 45 equals x squared. I need to square root both sides. X equals the square root of 45. Since we're doing a practical example, we can just plug that in, 45. And we get a decimal with some numbers. That's okay, about 6.7. So we found this to be 6.7. We had a square inside of a circle. Seemed like an impossible task, but we had some things to help us. We had our right angle, letting us know these getting cut in half. We had our diameter to tell us how far our radius is from the center. And then we just put it in our little right triangle. So this problem really uses a lot of pieces. Hopefully that sort of makes some sense. If not, if you look on the slides, they'll go through it step by step. They find C to E, D, E, A, B. They're going to talk about each different step. Okay. Where did I go wrong? Oh, I see where I went wrong. If you found where I went wrong, good for you. Make sure you do not forget your normal arithmetic. So 4 squared is not 36, it is 16. So this should actually be 81 minus 16. That becomes 65. 65, square root of 65. Oh. and we end up with 8.06. Let's see, does that match? Perfect. So yes, once again, your teacher is human too. So don't forget, we tripped at the finish line, but everything else made sense, hopefully. So we have a very, very similar question. I'll do this one as well, just so we get more practice and we get to see it again and again. It's the exact same kind of problem. If I were you, I would take some time and try it yourself, just so you have a little bit of practice on your own. And then I'll do it in a second. So if you want to pause the video now, so you have your own time to try it and find where your questions are. And maybe when you see me do it afterwards, you can know what to do. So pause the video, give it a try, but I will do it myself. So we have diameter QS is 14 inches. Remember, 2 tick marks for inches, 1 for feet. RT is 10 inches. And we are looking for the exact same section. So once again, I'll take a color. Let me know what I'm looking for. I want this right here, hopefully with no mess ups. Okay, well, so what do I know? I know R to T is 10. That means I have to cut this in half, so that's 5 and 5. I'm also going to make another right triangle. So this is my right triangle I'm going to solve. I'm going to have one of the legs. What is this? This is U, this is R, and this is V. So I know my leg is 5. I will not know that. That's my thing I'm figuring out. We have V to R again. That is a radius because it'll go from the center to the outside, which is half of 14, so that is going to be 7. So we have 7, 5, and something. 7 squared equals 5 squared plus x squared. You can use A, you can use B. I would not recommend using C because that is normally reserved for the hypotenuse. Okay, let's make sure I did this math right. Minus 25. 24 is x squared, so x is about, even by not doing it, I know it's less than 5, like 4.9, because 5 squared gives me 25. 24 has to be a little less. So I'll put in my calculator. 24. And I get 4.89. All right, moment of truth. Is that one of my possible answers? I got 4.9 for C. That seems very reasonable. So 4.9 it is. Great. Great, great, great. Theorem 10.5, you're doing very well. We're not, we're so close to being done. Thank you for your attention. In the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. Equidistant from the center. If I can show you another thing, these chords, so the more we add like chords, not just diameters, because there's a seemingly a normal amount of diameters we could have, but chords are sort of infinite. We can keep adding different ones. Let's see if I have anything I can use. Well, I don't have anything. So let's just use the pen. If I put a chord across the middle, you see it has to stretch the whole pen totally, but as I keep going, it's going to use less and less of the pen to go across. So chords are smaller to the edge and bigger towards the middle. So if I have my center, and I have one chord here and one chord here, and I tell you for sure, once again, not to scale ever, that these two spaces are the same distance apart, then I can know that these chords are the same length as well. Once again, the further away a chord is from the center, the shorter it has to be to go end to end. But as you get closer and closer, it has to get bigger and bigger. That's why these two sizes, if they match, then the chords themselves match. So we have something like this. We're given that MP, EF, and GH both make 24. So if I want to find PQ, that is a radius, how would I do that? Well, if you see here, there's a little tricky thing. You're actually given PR. This is not a matching leg. So be careful. This is E to Q, I believe. Maybe it's E to Q. But we're given 2x plus 3 is PR. So no matter what, we still know how to do this. 4x minus 3. Okay, so both of them are going to be your Q to P, P to R. So we're going to set those equal to each other, and we get PQ is 9, X is 3. Here's the one last one. We have 3x minus 6 equals 8x, x plus 8, sorry, x plus 8. So we have 3x minus 6. We have x plus 8. We're given that MN and PO are 29. What that tells us is sort of backwards that this and this work, so I know these have to work. So I know that 3x minus 6 and 8, x plus 8 match. So I can subtract x, subtract x. So 2x is 14, move the 2, move the 2. X is 7. That's probably not what it wants. It probably wants us to plug it back in. Find RS. RS is 7 plus 8. So we get, let's pick a different color to celebrate finding the correct answer. 15, is that an option? It is. It is option D. And we got it. Just barely. You can see it almost didn't pick D. It was very close to picking empty blank space. All right, that is 10-3. We talked about chords and a lot of relationships, a lot of things that match. If you want to go back, you could look and sort of see all the sort of things are really just saying, if this works, then this matches. Matching is a big thing. We have cutting in the perfect sizes. We have talking about triangles again. If something was not clear, make sure you reach out to me, watch the video again, maybe find another video where they do it a little better than what I'm trying to do, but hopefully 10-3 arcs and chords make sense. I will see you all very soon. Good luck.